Hi guys. In this video I'm going to cover test-driven development, TDD as you may have heard it described. Also cover red-green refactor, or at least describe what that is. And a little bit of coverage of JUnits, how you write a JUnit for test-driven development in Java. The various methods within a JUnit and what asserts are and how you use them. Sort of the strategy behind writing a JUnit and adding tests to it. So let's go right to it. I have a demo project open here in Eclipse, and as you can see, I have a inside our test folder over on the left. There's one package with a single JUnit class in it, this template test class. I have it open in the editor. This is a JUnit. If you've heard JUnits described, the JUnit is just a unit test. It's mostly used for unit tests of Java classes. So you're writing a class, a Java class that represents a unit test of another Java class. Now the unit test tests a single class. In this case, when it's a unit test, that is. You can also use JUnits to write other types of tests, such as integration tests and others that may test more than one class. But in this case, we're just going to cover a unit test and how you develop one in test-driven development. So you see that this JUnit has the imports for the JUnit library. And inside of it right now are only two methods, a setup method and a teardown method. These were generated by the Eclipse JUnit wizard, which I used in a previous video. I hope you guys liked that video. But I used the Eclipse IDE wizard to generate a new JUnit, and it created one with this boilerplate code. The setup and the teardown method are optional. They're each optional. You don't necessarily have to have either one, but they can come in handy if you need to set up resources or initialize class level variables, things like that, open database connections. And the setup method runs once before every test. The teardown method runs after every test, and that makes sense based on the annotations. Now in JUnit 4, which is what we're using, everything is annotations driven. So inside your JUnit, the JUnit framework and the test runner will know that this method called setup is to be run before every test because it has the @before annotation. And likewise with the teardown method, the @after annotation tells JUnit that it should be run once after each test. Now there are no test methods in our JUnit yet. We are going to write them as we do test-driven development. Now what is test-driven development? You've probably heard TDD referred to a lot. Test-driven development is just a methodology or a strategy for writing tests that drive out your development. In other words, they drive the direction and the extent of the code you write or the code that you add to your application. So in other words, you're not starting by immediately going from your requirements to writing code that you add to your application, and then afterwards testing that code, that new functionality. Let's say you have a story and you have requirements from your client or whatever to add a feature to your existing application. Let's say the feature is to add email, or let's get more specific for this demo. Let's say you have a requirement to create functionality to create formatted messages, formatted text that would report a student's score on an exam. And that functionality should take as inputs a template, like some template text, and it should take basically a student's score on an exam. Let's say it's an int. And it should take those two things, and when the proper method is called, it should return a formatted message, a string that's formatted with the score for the student's exam in it. So that's one example of a requirement that you might be implementing from a story in your agile development. So in test-driven development, you would write the test for that behavior or that functionality first, and you would most likely break it down into a number of test methods to get fine-grained, so that you normally you will be writing at least one test method for every real method, every method that's in your class under test. And you most likely, if you're doing a good job with TDD, would be writing more than one test for each real method in your class under test. And the reason for that is as you may know just from computer science in general, that you want to test not only the happy path, but also edge cases and unhappy paths. And what that means is you want to test your code that it behaves the way it should under normal conditions or under ideal conditions. But you also want to test how it behaves under suboptimal conditions, under unusual circumstances. And that's analogous to testing of hardware too. You want to test it under normal operating conditions, but you also want to test it under extreme conditions to get benchmarks, for its quality. Same thing with code. You want to test your code under unusual circumstances, such as what if you feed it a null instead of a valid string? What if you feed it an empty string? What if you feed it a string that it does not have the proper syntax or follow the proper pattern? What if you supply it with a negative integer? Things like that. Unexpected circumstances. Now, in this example, we're going to be using TDD for functionality that's very simple to keep this to a short video. But in reality, most likely you'll be working on functionality that's a lot more complex. Maybe it connects to a database, maybe it creates and sends an email. So there's a lot, in those cases, there'll be a lot more code to write, a lot more logic, and a lot more dependencies to other classes and to outside external resources, such as mail servers or databases or other servers or websites or APIs, web services. And so for those external dependencies, you may need to mock them, create mocks of them, or do other things, set them up, initialize them, open connections. And those sorts of behaviors, that's kind of setup that you need to do before every test, you would write that into your setup method. Conversely, you may need to disconnect from them or shut them down, shut down a local server or something. Or you may need to clean up resources or close connections after every test. And that's the kind of code you would add to your teardown method. Now, either one of those two methods, the setup and teardown, are optional. You don't have to have either one, but they can come in handy. They do serve a purpose. And if you do need them, feel free to add them. And in fact, you can add more than one setup method and more than one teardown method if you like. The names of those methods is unimportant. It's all based on the annotation. So a setup method is any method that's public and void that has the @ before annotation. And likewise with the teardown method. As long as it's public and it has the @ after annotation, that's a teardown method. So now it also needs to have, they need to have that same signature, public void, throws exception. Now, there are no tests in this JUnit yet, but in test-driven development, as I said, we start from the test. We start with no code or no functionality. We have not written any code yet for this story, but we start from writing our test, and we expect that test to fail. That's part of the TDD cycle. In test-driven development, you write a test. Before you write any code for your functionality, you test that the functionality exists and works as you expected. And then, of course, the test is going to fail, or at least you expect it to fail. You run the test. You get red in the test runner from a failure, hopefully. And then you move on to, once the test fails, you then move to go and write the code necessary in your app, or add the code to your app to make that test pass. So at that point, that's when you do, the actual programming of adding code to your app or to your program to add the behavior necessary to get the test to pass. At which point you'll see green in your test runner. So there you see the red and the green. The red of the failing test first, and then you write your code to make the test pass, and then you get green when you rerun the test. because the test is passed and it shows as green. So there's the red and the green of red-green refactor. That's the other concept I mentioned that we were going to talk about. Red-green refactor is just a description of the cycle or the sequence that you follow in test-driven development, where you have your failing test, the red, then the passing test, the green, and then you get a chance to refactor your code. So that's the point at which you would go in, if necessary, if it warrants, and you would refactor the code that you just wrote to make it more ideal and efficient and so forth, or maybe improve variable names, things like that. Okay, so let's get to it. I'll show you kind of a demo of that. I've got a demo project open here. No code yet, no class yet. We're going to start from the very scratch. Now, in a real-world scenario, you might already have an application, you might already have classes, and you're just adding, when you begin developing TDD, you're just adding more functionality to it, an additional feature. And in that case, then you would write a test for the new feature, but you would be adding your code to the existing code base. But in this case, we're going to drive out the code right from the get-go. So we're going to actually create our class when it's required by the test, by a failing test. So let's do that. First step, write your test. This is the for the red phase. Now, this is an example of a test method, so named because it has the @test annotation. And it is within test methods, and they must be public void, and they can have any name. Within test methods, you will actually add the code, write the code necessary to test the behavior, to test that it exists and it works as you expected, and that it returns the values you expect, and that it has the side effects that you expect. Whatever is required. So in this case, we're going to do a very simple test first, and this is how you should work in TDD, for, iteratively, incrementally, slowly building up functionality from simple to complex. So let's say, as an extreme exaggeration or example of that, we start by just testing that we can actually instantiate a template object, because the name of this test is template test. And I described how our story calls for a template object that we can construct and that can create a formatted message containing a student's test score when we provide it both the string, which is the template, and a score as in the form of an int. It should combine those two things and return a formatted message. So let's first just test that we can construct a template. Well, we can't. We're getting red at this point. We're not getting a failing test, but what we're getting actually is that we're getting build errors in our editor because we can't even build the test yet. So you see that there are errors in the existing project. If we were to run it at this point, and launch our JUnit runner, we get red because we don't even have that type. We have not even created a class named template yet. So let's go ahead and do that. We've got our red phase already. Let's create class template. And we want to add whatever code we need to get this test to pass. So we need to at least create a class called template, and you see that the new class wizard already has populated that name. It'll extend from object. We don't need to inherit any methods from object. We're going to write our own methods in that. Let's create it. Adds it to the source folder in the Package Explorer. So we have our class template. Now that should have a default constructor. Default zero argument constructor automatically as part of the Java language. So let's test that by rerunning the test. Can we sorry, we're not testing anything yet. To the test, we need to add an assert. We need to assert that this template is not null. So we'll assert not null on the template. Now here we come to asserts, the other element that I wanted to talk about. And how do you actually verify and actually test anything in a JUnit? How do you do that? Well, the main way is through asserts, and that's part of the Java language. An assert just asserts that a certain condition or a certain object or some scenario that you specify is true or is valid. And there's all flavors of asserts. There are many different kinds. Assert not null, assert null, assert true, assert equals to compare two values, assert not equal, so forth. There's many different kinds of asserts, and there's also other libraries you can add on besides JUnit, libraries like Hamcrest, Mockito, and others that further extend the number of matchers and asserts that you can do, and tests ways that you can test even further. So we've got an assert to make sure that our template is not null, that we can instantiate it. This should pass now because of the default zero argument constructor that any class comes with it in Java. So now we have our green, our test is passed. We can construct a template. But we know that we need to construct it with a string. So let's test that we can construct a template with a string. And I'm going to kind of copy this code and just modify it to save some time. And we'll supply this string s to the template and assert that the template is not null. But we see our first problem. We've already got some red here. Let's ignore that. Go ahead and run the test. And I'm showing you how to run the test in the JUnit test runner using the menus, using the context menu, because it's hard to convey the concept of a hotkey in a video. In a video, you can't see the hotkey. So I'll show you how to do it via the context menu. We run this test, can instantiate with a string, and that one fails. In fact, let's run the entire JUnit. If we run that, we should get one passing test and one failing test out of the two tests. And because we have a compilation error, Eclipse will warn us about that first before we even run the test. We're going to ignore that to demonstrate the idea behind test-driven development. And you see one is failing and one is passing. We have one error and out of two runs. And we still get red because that instantiate with a string is not yet passing. So what do we need to do to get it to pass? Well, we see that first it has a compilation error. It's just simply not building because that constructor that takes a string does not exist. So let's create it, and Eclipse prompts us to do that through the magic of code completion. So Eclipse has generated a one argument constructor taking a string. Right now we don't need to do anything with that string in order to make the test pass. The test will pass automatically. We see we have a problem because we now need to explicitly supply a zero argument constructor also. This is kind of just basic Java language stuff, so that'll make sense to you, and that you'll understand why if you've done a little bit of Java programming. It's just the nature of classes and constructors. So now we have a zero argument constructor, and let me move this below the zero argument constructor. So we now have a zero argument constructor and a single one argument constructor that takes a string. So I'm expecting that we can get both tests to pass now. And if we rerun this test, we should be able to get it to pass. Get both of them to pass, that is. And you see that they do. We have green. Both tests are green in the test runner. 0 errors, 0 failures, and 2 out of 2 were successful. You'll notice also the JUnit runner shows you the execution time of each test. Okay, well, are we done? No, because right now all we're doing is constructing one of these template objects. It doesn't do anything yet, so we haven't satisfied the requirements of our story. We need to add, actually, before we add our additional tests, we can go in to the template class, and we have a chance to refactor now. Well, let's first remove this comment here. Now, there's not much to refactor yet. The class is still very simple. However, I do see something, which is that the parameter name for the supplied string argument, that is kind of a meaningless name. It's just S. and it doesn't really indicate what that variable or what that parameter does or what its purpose is. So let's give it a more meaningful name. We know that this supplied string becomes like template text. So let's call it that, abbreviation. And we just use the refactoring feature on Eclipse to do so. Let's see, anything else we can do? We've got a constructor, we've got two constructors here. Not much code yet that would allow for us to really refactor, except maybe clean up some of the white space here. And one thing we can do is maybe run formatting to on the source code to actually align all of the indentations and the braces and so forth. That's a form of refactoring, so let's save that. And after refactoring, it doesn't hurt to rerun your test, although it's not required. Refactoring is not normally going to change any of your functionality or cause any of your tests to fail, but it doesn't hurt to be a little defensive. So of course they pass again. Now we need to add a new test to drive out more functionality. So currently our template class doesn't do anything. We can construct it, but we can't do anything with it. So let's add a test to see if we can call a render method on it to actually get back, and that the render method will return a string. I'm going to copy the code again to kind of speed things up. We construct a template object with that string, and we want to call a method on the template called render, and we want to return a string. So let's capture the string by calling render. Hang on, it's a little lagged. Getting a little bit of lag. Okay, there's our render call. Now we know that when we run this, let's add an assert there. Assert. We want to assert that the return string is not null. Okay. Now this should fail already because we can see it has compilation errors. If we run it again, we should get a failed, and we'll have to skip past that warning. We should get a failed test, and we do. So that's because of the compilation error here, which is that this render method doesn't even exist. So let's create it in the template. The method has been created, and it needs to return a string. Right now, we don't have a string to return it. We receive a string in the constructor call, but we don't store that anywhere. So we just need to return a string at this point, so we could return an empty string, and that would satisfy our test. So let's see if that does satisfy our test. By rerunning the test, and you see that it does. We get green. So now we can go in and refactor. Well, I do see something glaring at me, which is I see that the variable name of the string that we're passing into our template in the constructor is a meaningless name. It's not a very meaningful name. It's just S again in the test this time. So let's refactor that and rename it to something more meaningful. Call it the pattern, I guess. Okay. Now, what else? What might we want to do here? We can possibly inline some of this code to make the test code more succinct. We're storing the return string in this variable, and then in another line we assert on it. We can inline that so that we get rid of line 41, condense our code, and still have the same functionality for the test. Within the test class, There's not always anything to be refactored. Um, I don't really see anything standing out at me that I want to refactor. There are changes that need to go into this class, but those would not be refactoring. Those would be adding functionality. So for now, I think the refactoring phase is done. So now, after refactoring, we should rerun our tests always. It's good practice. Make sure they still all pass. And they do. We get green. So now our red-green refactor and cycle is done. And so let's move on to the next iteration of it, where we need to add some functionality. Right now, our template class is looking good. It returns, you can construct it, and you can construct it with a string. And when you call its render method, it returns a string right now that's not null. But we don't know if it returns the actual message it needs to return. It needs to return the message your test score was, and then a number. And the number should be supplied to the template in the render call. It should be an int that's supplied to it. But we don't know if it even does that yet because we don't have anything testing that. So we need to add a test for that. So we'll test that if we pass the render method an integer value, which is a test score, that it returns the proper message as a string. And I'm going to copy this code here to get us started, because the functionality in this new test is quite similar but not the same. So we have our pattern that we've constructed, and we construct a template from that pattern, and then we call render. We know that we need to return, we need to pass into render an int, which is the score. Actually, here we just need score, and we'll need to define that variable score. Okay. Now we run into our first problem, which is that the render method does not currently take an integer. So let's change the render method to allow for it to take an integer. And we've made that change. The render method now takes an integer. We go back to our test, and we see that our first test was not set up to pass it an integer. It was not yet coded to pass an integer. So here, let's pass an integer to make that compilation error go away. Now, so far in this new test method, render method returns proper message, we're only asserting that the returned string is not null. But that's not what this test is. That's not all of what this test needs to do. As you can see from the name, it also needs to make sure that the returned string is not just not null, but that it's the right message. So what is the right message? That's the expected message. And we know what it should be based on our story. It should be your test score was, and then at that point, there should be a number appearing in the string. Now we know the score is 90, so we could use some string concatenation here. We could do plus score. So that is what the expected message should be. Your test score was 90. Now let's assert that the expected message equals the returned message. So if we assert equals, and then a call to render with the score. So here we are actually testing that the returned string dot equals the expected message. Assert equals just simply does a comparison of the two arguments using dot equals. And of course they should be two objects of the same type or assignable for dot equals to work. So let's go ahead and run that and see if it works. Sorry, got a pop up. Okay. and we can expect it probably to fail because we have not added any functionality that would create that template. And you see that our new method, our new test method, does fail because it's not returning the proper score, proper message. So we need to change our class to make it return the proper message. So you see our class is receiving a score as an integer, and it needs to return it needs to take the template text and somehow modify that to return the proper score. But we don't have access to the template text inside of render because template text is passed in the constructor of template, but then it's just discarded. It's not saved anywhere. So we need to first save that as a field in the class. Okay, so now it's a class member, a field, so we'll have access to that template text inside of our render method. So now what if we just try returning the template text? And I'm going to kind of play dumb here just to kind of demonstrate the proper procedure, the proper flow in test-driven development, because this is simple enough code that I can work it out in my mind, and you can too, to know that this is wrong, that this won't cause the test to pass. But we're replicating a real-life scenario where you may have code, you may be testing code that is much, much more complex, and it's harder to discern in your mind whether or not you have fixed the problem. And so using test-driven development, you're going to find that out because you're going to rerun the test and you're going to see whether it passes now or if it still fails. And you see that it still fails. And if we click on that failing method, we can verify the reason why it fails. And you see down here in the runner window, it actually tells us the comparison failed, the assert equals failed. It was expecting a message of your test score was 90, but the actual result was your test score was and then a blank. So our test is still failing. That means we deviate from the red-green, we kind of deviate from the three-step process because we need to go back over and repeat the cycle to modify our template class to get that behavior that we need for the test to pass. The behavior is it needs to take the template text and in the render method it needs to take the score and combine those two things and return a string that is a properly formatted message based on the template. So based on our programming knowledge, we know that if we do string.format and we supply as the string to format the template text, and as the second argument we use the score, that's one way to create a formatted string. So we can return that formatted string from our render method. Now we see what we're constructing here. This probably, we know from our own experience, we know this is not going to pass because we don't have a proper string that string.format can use. We would need a %d character. So instead of cheating, we'll rerun our test and expect it to fail at this point because we don't have a properly formatted string. Okay. So we need to modify. How can we get this test to pass? Well, this situation is a little different. We can see that we have the proper code, and maybe we study our code and we looked at the render method, and we see that everything looks right for this to work. But if we look back at our test, we see that the pattern that we're passing in as the constructor, that pattern text or that template text, that is wrong. Since we're using string.format now, we're going to need a %d here. and that's the substitution token for an integer, for that to be plugged in there. So what happens now if we rerun the test using this new test data? In this case, we've changed the test data. Let's try that. Okay, in this case it fails too. The reason is white space. So there's an extra space, in one of the two values. So in our pattern, we have a space after the colon. But in our assert, our expected message, we don't. So let's add that to our expected message. One space. Okay. Let's double check that. One space and one space. Save that and then rerun our test. Okay, and now it does pass. And let's run all the tests to make sure they all pass still. And you can always use hotkeys, the hotkey for rerunning your test. That's what I normally do. But I'm showing you guys how to do it through the context menu, because then you can actually see and learn where it is in the menu and how to actually rerun the JUnit. And you can see now that all of our methods are passing, and we've satisfied the requirements for the behavior. Excuse me a second. My window is acting a little funny. Okay. Yeah, so we've satisfied the requirements for our story, and the test of that behavior for the happy path is passing. So we're able to test that full behavior. We can go back in and refactor now. Let's say we want to refactor our test, and this score, let's say we want to make the pattern and the score class level so that we can reuse them many places. So let's actually move that pattern text out and make it a class level field. And let's make it yeah, I guess that's good. Okay, and then in our setup method we want to give it a value, assign it its value. Okay. And actually, I should change this. This is the pattern. Okay. And then in our tests, let's make sure that we use the proper one. We are using the class level one. And here, let's make sure that we're using the proper one. Now we're using the class level field. Okay, and let's do the same thing for the score. Actually, the score may differ. Thinking about it, the score may differ from test to test. You may want to try different scores, so let's leave that in our test method. And now we've refactored. Let's see about refactoring inside of the class itself. Okay. And let's think about this. We might want to might want to ensure that the score variable, or the score field, is, no, sorry, I take that back. I don't think that would matter. But what I want to do is space out these methods a little bit, and let's say we want to rename, let's say we want to Oh, actually, I see a good point for refactoring. This argument is named score. Now, in our case, in the case of this story, we know that in our case, in this test, it's a score. In the particular test that we're running, it's a score. But what if we want this template class to be more universal and to be usable for other things than just exam scores? What if we want to use it for ages, somebody's age or something, because it's completely customizable like that. Well, then we don't want the name of that variable to be score because that's very specific. Let's rename it to something more generic, such as value. Okay, and we've done our refactoring. So we've made a few changes as part of our refactor phase. Let's rerun all the tests and make sure they still pass. And you can see a little compressed, but they all pass now. And then from that point, we have now what we have is that we've refactored our code and we have a happy test that's passing. The only thing left to do is to add further tests for edge cases, error paths for our given functionality. And then from that point, you would move on to the next story, the next piece of functionality. So in an edge case, I can give you kind of an example of that. Null template text throws render throws exception with null template text. Render throws exception with null template text. Okay. We want to test that the render method of our template will throw an exception if a null template text is passed to it. And I already see at this point when we get to our refactor phase, we can move some of these things out into the setup method and make them class level because we're doing the same things over again. But if we want to make sure of that, let's say we construct a new template. Pass in a null in the constructor, so it does not have any template text inside of it. So we take our expected message, so then we would call template.render and pass it some integer, say 23. And we expect that would return a string. Template.render. Now, instead of adding asserts in this case, with JUnit, we want to check or assert or verify that when we do this, it will throw an exception of some sort. That's what we want to test, that it throws an exception. Okay? Now, instead of doing that with asserts, the way we do that in JUnit 4 is we add an argument to our test annotation, our @test. We added the argument expected for the expected exception. We expect that it'll throw some sort of exception. So if we add that there, let's run this test. Now in this case, this is an edge case test, and it should probably fail. Or it should probably pass, I'm sorry, because we expect the exception. Now a better way to have done that, actually, is we write our test to expect that it throws an exception here. And we run our test, and let's say we assert that the formatted message equals the expected message. So let's copy this code in. Okay. So if we rerun that, let's see. Okay, so if we rerun that, that test should fail. Yes, it does, because we're not getting back, we're getting a null pointer, we're not getting back any string at all. So we should expect an exception. Now, we could, add code to process that exception somehow, or I'm going to show you how you can set your test itself to expect an exception. You do that by adding an argument to the test annotation. Let's add the argument expected. And with expected, you can supply a type of exception that you do expect. So that's a bit of a tongue twister, but you can you can specify a given exception type that you expect to receive by supplying its class type. So let's do that. We expect an exception. If we rerun this, we should get passing now. I expect. We'll find out. Yes, we do. So this new method tests an edge case and not the happy path, and it does pass. So let's rerun our entire JUnit and make sure that all our tests are passing. And there you have it, guys. 5 tests run out of 5, 0 errors, 0 failures. They all pass and they're all green. So that's kind of in this short time that we have for this video, that's kind of a simple demonstration of test-driven development as well as red-green refactor. And we went over the basics of a JUnit and what's inside it and how you use it to test a Java class and how to write a unit test, as well as covering the basics of asserts. Just to kind of sum up with asserts, there's a number of them available. You can look through the JUnit documentation. You can also look through the static imports that you can do. But some of the basics are assert not null, assert equals, assert true. With assert true, you supply an entire expression. And if the expression evaluates to false, then your assert fails. But if it evaluates to true, your assert passes. Okay, guys, well, hope you liked the video. Hope it was helpful. Look at some of my other videos, and good luck. Happy coding.